number 14, we are looking at the sum as n goes from 1 to infinity, and we have n to the nth power. Yes, oh my god, this is n to the nth power. It's like, again, like the big boss, like Thanos, right? But on the bottom, we have the infinite stone. We have 3 to the n to the second power. First of all, let me tell you, without the little square right here, we can just say that this right here diverges by using the list to show that an does not approach 0. But anyway, we do have the n squared for the power for the 3, so we have more exciting things going on. So let's take a look. Both of them have the nth power, and here, and this is n squared. It's a good idea to take the root, the nth root test. So let's go ahead and check the following. Right? So as n goes to infinity, what we are going to do is we'll just take the nth root, and when you do the nth root, you put the absolute value, but even though everything is positive, so in this case it doesn't really matter. So we will have n to the n over 3 to the n squared. We'll check this limit to see what we get, right? So let's see. This right here, it's just divided by n. Remember, when you take the nth root, just do the top and bottom. So here we have n to the n minus, so over nth power, and then the bottom is 3 to the n squared, but divided by n right here, right? And now here is the beauty of this. Take a look. On the top is just n to the first power. On the bottom, we have 3 to the n, like that. Very nice, huh? And now, as n goes to infinity, can we draw any conclusion? Yes, we have infinity over 3 to the infinity power, but by the list, we know the top infinity is smaller than the bottom infinity. How much smaller? So small, when you divide this by that, you go to 0. And you can put this down and just say by the list. Right? So that's pretty much the idea. And remember, here we are using the root test. So can the 0 help us? Yes. And you have to compare the 0 with 1. In this case, if you do the root test, if you end up with 1, unfortunately, we have to do more work for that. But thankfully, this right here is 0, which is less than 1. So we can just say by the root test. So this right here actually converges, and we will just write down by. Unfortunately, here we cannot abbreviate root test because ratio test is also RT. So we'll just spell this out. Converges by the root test, just like that, right? So that's it, which is pretty good, pretty good, pretty good.